Good morning, students. Once again, this is your science teacher, Mr. James. Are you ready for another lesson? Great. Before we start, I want you to get the following materials. First, your science textbook, your science workbook, your pen, and your earphone. Before we start with our new lesson, let's have a quick review in our previous lesson. Do you still remember the title of our lesson last week? Great. Earth in Space. How does Earth move? Earth moves in space in two major ways, rotation and revolution. Rotation. The imaginary line that passes through Earth's center and the North and South Pole is Earth's axis. The spinning of Earth on its axis is called rotation. Earth's rotation causes day and night. It takes Earth 24 hours to rotate once. We call that cycle a day. Next is revolution. Revolution is the movement of one object around another. One complete revolution of Earth around the Sun is called a year. Earth follows a path or orbit as it revolves around the Sun. Earth's orbit is slightly elongated circle or ellipse.
Talking about the Earth's axis. The Earth rotates on an axis. The axis is tilted at an angle of 23.5 degrees. The Earth rotates around its axis once a day. The tilt of the axis affects when seasons occur. When the axis tilts toward the Sun, the northern hemisphere experiences summer, while the southern hemisphere experiences winter. In half a year, the Earth will revolve elliptically counterclockwise around the Sun, while the axis stays tilted at 23.5 degrees. When the axis tilts away from the Sun, the northern hemisphere then experiences winter, and the southern hemisphere experiences summer.
What causes seasons?
You know that Earth orbits the Sun, right? And that it takes a full year for our planet to complete its orbit? Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit the Sun. But that means the Sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Observe how the North Pole tips away from the Sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool, with short days and long nights. As Earth orbits the Sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the Sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of our orbit. The North Pole is tipping toward the Sun. Sunlight strikes the northern hemisphere more directly, and the Sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the Sun stays in the sky much longer. Notice too that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed. We observed how Earth's tilt creates the different seasons throughout the year.
Equinox and the solstice. Because the Earth is tilted at a 23.5 degree angle and also rotates and revolves around the Sun, The length of the day varies throughout the year. During each equinox, both hemispheres receive almost equal amounts of sunlight, 12 hours of daylight and 12 hours of nighttime. The actual day in which both hemispheres receive 12 hours of sunlight and darkness is called the equinox, and usually occurs a couple days before the March equinox and a few days after the September equinox. The day of a solstice in either hemisphere has either the most sunlight of the year, which is the summer solstice, or the least sunlight of the year, which is the winter solstice, for any other place on Earth other than the equator. Does the sun always set due east and set due west? Actually, the sun rises in the east and sets in the west only 2 times a year in each hemisphere. In the northern hemisphere, on March 20th, which is the first day of spring, also called the vernal equinox, the sun rises due east. Moving forward, the sun then starts setting a little more northeast. The sun continues to set a little more northeast each day until June 20th or 21st, which is the first day of summer, also called the summer solstice. After the summer solstice, the sun starts setting less to the north until September 2nd, which is the autumn equinox, or the first day of autumn. On this day, the sun sets due east again. After this day, it will rise a little further southeast until December 21st or 22nd, which is the first day of winter, also called the winter solstice. After this day, it sets a little less south until March 20th, which is the spring equinox. It takes 1 year to complete this cycle. In the southern hemisphere, the first day of spring is September 22nd. The summer solstice is between December 20th and 22nd. The autumn equinox is March the 20th, and the winter solstice is June 21st.
The title of our lesson for this week is Phases and Eclipses, pages 492 to 497. Objectives. After this lesson, students will gather and synthesize information to explain what causes the phases of the moon. Students will apply scientific principles to describe solar and lunar eclipses. Vocabulary words. At the end of the lesson, you will be familiarized with the following words. First, phase, eclipse, solar eclipse, lunar eclipse, umbra, and penumbra. What causes the moon's phases? Have you ever been kept awake by bright moonlight? The light streaming through your window actually comes from the sun. The moon does not shine with its own light. Instead, it reflects light from the sun. The different shapes of the moon you see from Earth are called phases. Here are the phases of the moon. Phases are caused by motion of the moon around Earth. Motions of the moon. Like Earth, the moon moves through space in 2 ways. The moon revolves around Earth and also rotates on its own axis. The moon rotates once on its axis in the same time that it takes to revolve once around Earth. A day on the moon is the same length as the month on Earth. As the moon orbits Earth, the relative positions of the moon, Earth, and sun change. So when we say relative position, is a point established with reference to another position that is either moving or fixed. The changing relative positions of the moon, Earth, and sun cause the phases of the moon. Phases of the moon. Half of the moon is almost always in sunlight. But since the moon orbits Earth, you see the moon from different angles. The phase of the moon you see depends on how much of the sunlit side of the moon faces Earth. During the new moon phase, the side of the moon facing Earth is not lit. As the moon revolves around the Earth, you see more of the lit side of the moon until you see all of the lit side. As the month continues, you see less of the lit side. About 29.5 days after the last new moon, a new moon occurs again. The lunar month is the 29.5 days it takes to go from one new moon to the next. During the lunar month, the moon goes through all its phases. So we will discuss all the phases of the moon. First, when the moon is in between the sun and the earth, we cannot see the moon. This part of the moon is in the shade. This is called a new moon. Next is what we call waxing crescent. The moon is less than one-half illuminated by the sun, but less than one-quarter illuminated. The first quarter moon is a primary moon phase when we can see exactly half of the moon's surface illuminated. If it is the left or right half depends on where you are on Earth. Next phase of the moon is what we call waxing gibbous. Waxing means that it is getting bigger, and gibbous refers to the shape, which is less than the full circle of a full moon, but larger than the semicircle shape of the moon at third quarter. When the Earth is in between the moon and the sun, we see the whole part of the moon which is lit up by the sun. This is called a full moon. Just after full moon, when the face of the moon is 100% illuminated, the intermediate phase called waning gibbous moon starts. Waning means that it is getting smaller, and gibbous refers to the shape which is less than the full circle of a full moon, but larger than the semicircle shape of the third quarter moon. Last quarter or third quarter moon, the phase of the moon at which the moon as viewed from Earth appears to be half illuminated by the sun on its easternmost side. During the waning crescent moon phase, the illuminated part of the moon decreases from the lit up semicircle at third quarter until it disappears from view entirely at new moon. Waning means that it is getting smaller, while crescent refers to the curved shape similar to banana or a boat. New moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent, new moon. So when you say waxing means getting bigger every night. Waning means getting smaller every night. Crescent means less than half of the surface of the moon facing you is lit by the sun. And gibbous means more than half of the surface of the moon facing you is lit by the sun. What are eclipses? The moon's orbit around Earth is slightly tilted with respect to Earth's orbit around the sun. As a result, the moon travels above and below Earth's orbit, but on rare occasions, Earth, the moon, and the sun line up. When an object in space comes between the sun and a third object, it casts a shadow on that object, causing an eclipse. There are two types of eclipses. We have solar eclipses and lunar eclipses. The words solar and lunar come from a Latin words sun and moon. Solar eclipses. During a new moon, the moon lies between Earth and the sun. A solar eclipse occurs when the moon passes directly between Earth and the sun. The moon's shadow hits the Earth. Total solar eclipses. The very darkest part of the moon's shadow is the umbra. Within the umbra, the sun's light is completely blocked. Only people within the umbra experience a total solar eclipse. During the total solar eclipse, the sky grows as dark as the night. The air gets cool and the sky becomes an eerie color. Next is what we call partial solar eclipses. The moon casts another part of its shadow that is less dark than the umbra. This larger part of the shadow is called penumbra. In the penumbra, part of the sun is visible from Earth. So this is an example of partial solar eclipse. Next is lunar eclipses. During most months, the moon moves near Earth's shadow but not quite into it. A lunar eclipse occurs at a full moon when Earth is directly between the moon and the sun. Remember, during a lunar eclipse, Earth blocks sunlight from reaching the moon. Lunar eclipses occurs only when there is a full moon because the moon is close to Earth's shadow at that time. Total lunar eclipses. Like the moon's shadow in a solar eclipse, Earth's shadow has an umbra and a penumbra. When the moon is in Earth's umbra, you see a total lunar eclipse. Unlike a total solar eclipse, a total lunar eclipse can be seen anywhere on Earth that the moon is visible. Partial lunar eclipses. For most lunar eclipses, Earth, the moon, and the sun are not quite in line, and only a partial lunar eclipse results. A partial lunar eclipse occurs when the moon passes partly into the umbra of Earth's shadow. Solar eclipse versus lunar eclipse. Solar eclipse. A solar eclipse can only occur at new moon, wherein lunar eclipse can only occur at full moon. The maximum time of a solar eclipse is 7 minutes and 40 seconds. For lunar eclipse, the total phase can last for a maximum of 1 hour and 40 minutes. A solar eclipse occurs when the moon passes between the Earth and the sun, wherein lunar eclipse occurs when the Earth passes between the sun and the moon. Let's summarize our lesson.
When you look up at the moon night after night, it appears to slowly change shape. These changes, known as phases, are repeated every month. This is because they depend on where the moon is in orbit around the Earth. a journey that takes 29.5 days. Notice that half of the moon is always lit up by the sun, and that half is always in shadow. From Earth, we see different amounts of the bright side at different times of the month. This is what causes the phases of the moon. When the moon is on the same side as the sun, we can only see its shadowed side. We call this a new moon. As the moon moves along its orbit, we see more and more of the bright side. The moon appears to grow, and we say that it's waxing. At first, we can only see a thin sliver of the light that reflects off the moon. We call this a waxing crescent moon. When the moon reaches a quarter of the way around its orbit, we can see half of its bright side. We call this the first quarter moon. As the moon continues, we see more than half of its bright side. We call this a waxing gibbous moon. When the moon reaches the halfway point on its orbit around the Earth, we can see the whole lit up side. This is a full moon. On the second half of the moon's journey, we see less and less of its bright side. We say that the moon is waning. First, we see a waning gibbous moon, where we can still see more than half of the bright side. When the moon reaches 3/4 of the way around the Earth, we again see half of the moon lit up. This time it's called the third quarter moon. We then see less than half of the moon, called a waning crescent moon. Finally, we see another new moon, and the cycle begins again.
Let's talk about solar and lunar eclipses. When the shadow of one celestial body, like the moon or the earth, falls on another, an eclipse occurs. A solar eclipse happens when the moon comes between the earth and the sun, and the shadow of the moon falls on part of the earth. A lunar eclipse happens when the earth comes between the sun and the moon, and the shadow of the earth falls on the moon.
Solar eclipses, we have two types. We have total solar eclipses and partial solar eclipses. Two types of lunar eclipses are total lunar eclipses and partial lunar eclipses. Thank you for watching and listening in our video. I hope you enjoy and you learn something from this video. Thank you.